Okay, so we're on the back of your notes from yesterday, and you have this graph in front of you. We're talking about the parent function, and the parent function means where does it come from? What is the most normal case for a quadratic function? And you all know that quadratic functions means the highest power is 2, right? Which means it'll make a parabola, right? Okay, so the most basic form that I can have up here is just plain old x squared. This graph in front of you is what plain old x squared looks like. Okay, which if I pull it up here on Desmos, this is plain old x squared, which is exactly what that looks like there on your paper, right? Some things that I would like to talk about. This point right here is called what? The vertex. The vertex is where, folks? Okay, what is the point of the vertex here? 0, 0. So that's always where this graph is going to originate from. 0, 0 is the vertex. Okay. The other important part that we need to look at in this parabola is how do I get from the vertex to my first point? Okay. We always have to go over 1. That's always a given. Hear me loud and clear here. We're always going to go over 1. Then I need to know how far do I have to go vertically? Up 1. And that's always going to be our A number. Okay, so the A here is 1. Everybody doing okay? I'm going to show you how to change this graph today and how different numbers in different spots can change this graph. They are called transformations. Everybody see that vocabulary word up there? A transformation is a change in position or size. A change in position or size. Specifically, today, we are only going to be changing the position, meaning we're going to be translating it. So I need you to understand that manipulating these parabolas are called transformations. Specifically, if I just want to change the position, meaning that I just want to move it, it's called a translation. How are we doing on the vocabulary there? Yeah? Okay. Well, there's 4 ways that I can move it. Okay? 2 of those ways deal with vertically. I either can move this thing up or I can move it down. If we're going to move it up, I just told you that the parent function is x squared, correct? If I take that x squared and I add some number off to the side, it's going to move it up. If I take that parent function, which is x squared, and I subtract some number off to the side, it is going to move it down. That should be pretty self-explanatory to you, right? Okay. Horizontal is not quite so self-explanatory. You guys know which way horizontal goes, right? Side to side. So I could either move this thing to the right, or I could move it to the left. If I'm going to move it to the right. Now, if I move it to the right, that is that direction, correct? If I go that direction on the x-axis, normally we're adding things, aren't we? Going that way. But it's actually the opposite. Okay, we are actually going to subtract a number inside of there to move it to the right. Which means if I want to move it to the left, I will then add a number on the inside. Notice left and right are going to happen inside of the parentheses, whereas up and down happen outside of the parentheses. Does everybody see that difference? So if I'm talking parentheses, we're talking about vertex form. Clear on this? Are you sure? Okay, I would like to show you what this looks like in Desmos. I got a whole bunch of graphs ready to go. Okay, so my first one here is just x squared. That's the parent function, right? Plain old x squared. Notice there's nothing around the x squared. Agreed? If I want to move it up, I have to put a number off to the side, which would be this one right here. So do you see how if I put that little +1 on there, it's now just shifted the whole thing up? Everybody good? If I subtract a number off to the side, it's going to shift it down, which would be that one there. So how we doing? A-okay? Up and down are good? Okay. Let's get rid of up and down. Now I want you to notice these next couple. You see how these are both inside the parentheses? If I subtract a number inside of the parentheses, it's going to move it to the right, which is the opposite of what you think would happen, correct? If I put a plus a number on the inside, it's going to move it to the left. Do you see how the shape stayed? The shape didn't change at all. I'm just moving it. How are we doing? Are you sure? You're positive. Okay. So if we have a number off to the side, we're moving up and down. If we have a number inside the parentheses, we're moving left and right. Fair enough? You sure? Okay, so let's go back to our notes then. And I want you to describe for me what would be happening to this graph. So the parent is the original, which is this piece right here, correct? You see the +3, right? What does that +3 off to the side mean it's going to be doing? It's going to be moving up. Up how many? It's going to be going up 3. That's all I'm asking you to tell me. Good? Okay. Number 2. You see the parent, correct? You see the -4 on the end? So what does that mean? It's going to go down 4. Okay. What's up with number 3? So how would you rewrite it? I'm going to rewrite it so it's in the correct order. I see the parent is right here. So what's happening to this graph? This is going to go up 5. Same thing happens in number 4. So how would I rewrite it? Oh, how about y equals? Okay, so here's the parent. What's going to be happening here? Down 1. You picking up what I'm laying down today? Yeah? Okay. Let's look at something like this. I see parentheses. The parent is right there. You see how it's kind of broken up? If I am adding 1 inside the parentheses, I know it's going to be either left or right. Typically, we think it's to the right because it's +1, right? But it's going to be to the left. It's kind of strange. This thing will be going left by 1. Here's the parent. The +6 is in parentheses, right? If it's adding 6, what's it going to be doing? Left 6. Okay, number 7, here's the parent. This one will be going right 4. So I want you to notice, folks, up, down, left, or right depends. Is it off to the side or is it inside the parentheses with it? How about this parent? What's happening to this parent? Right 3. Okay. So now the bottom row is we're going to combine them all. You're going to have more than one thing happening. Okay, so does everybody see the parent? Okay, tell me about the +3 on the end. Everybody A-okay here? Okay, tell me about the -2 on the inside. That's going to go right 2. You see how we got 2 things happening? Okay, number 10, here's the parent. What does the -10 on the end mean? And the +2? You guys are doing great. Anybody? Hold on a second. Anybody having any issues?
Do you have to do the one on, like, so, like, -10?
Uh-huh.
Do you have to write that one first?
No, it doesn't matter the order which you write them. Nope. What's happening with number 11? He says down 4 because of the minus 4 on the end. And then, which way? Right 4. Don't be in a hurry and thinking that'd be going to the left. And how about number 2? Okay, so don't put that away because I'm going to need somebody to read this to me because I actually want to show you these two things on a graph here. So let me get rid of all of these. Let's put another one in here. That one was, what was that equation, guys? Y equals?
X plus 9 parentheses squared plus 1.
I don't know. There we go. Y equals, what was it again?
X plus 9 in parentheses squared and then plus 1.
Okay, so if I get my graph back here and I zoom out, take a look. The orange one is the parent. The blue one is the new one. And we said that it was going to go up 1. Do you see how it kind of just snudged up 1 a little bit? And then it went to the left 9? It did, right? I'm not just making this stuff up. It really does. We all good? Okay, so you have to now finish your worksheet by telling me what's going to be happening to all those graphs.